Hi, everyone. In this video, we're going to look at some more examples of using complementary probability. But before we do that, I want to make a comment. So we saw before that if E and F are independent events, then the probability of E given F is just the same as the probability of E. And the probability of F given E is just the same as the probability of F. And so for independent events, so for more than two independent events, we can extend the product rule. And so if E1, E2, E3, and so on up to En are independent events, then the probability of E1 and E2 and E3 and up to En is equal to the product of all of these, P of E1 times P of E2 times all the way up to P of E sub n. And this only works if all of these events are independent. And so as a very brief example, let's say you flip 5 coins. What is the probability they are all, well, let's say 3 coins just to keep it small. What's the probability they are all heads? Well, so we're asking the probability of coin 1 heads and coin 2 is heads and coin 3 is heads. And so these are all independent. They're 3 different coins, so they have no bearing on each other. It's completely independent. And so this is going to be P of coin 1 heads times P of coin 2 heads times P of coin 3 heads. Well, the probability that any coin is heads is 1/2. So this is 1/2 times 1/2 times 1/2, which is 1/8. So 1 out of 8. Okay, and so we're going to use this idea and we're going to combine it with the complementary probability rule. So you flip 4 coins. What is the probability that at least 1 is heads? And so what does this at least 1 heads mean? It means you get 1 heads. So the event E is at least 1 heads. And that means that you could get exactly 1 heads, or you could get 2 heads, or you could get 3 heads, or you could get all 4 heads. And so we want to try to find the probability of getting 1 head or 2 heads or 3 heads or 4 heads. But we don't yet know how to deal with or. We know how to deal with and, we don't know how to deal with or. So how can we do this? Well, we're going to want to use our complementary probability. And so this is going to be a little tricky. A lot of times, the hard part of this complementary probability is finding what is the complementary event. And so what is E prime? Well, so what are all the possibilities? we could get, so possible numbers of heads. Well, you could get 1 heads, just like before. All of these are possibilities. You could get 1 heads, you could get 2 heads, you could get 3 heads, you could get 4 heads. But there's one more. You could also get or 0 heads. Okay. And so if this is E is 1 or 2 or 3 or 4 heads, then E prime is 0 heads. Okay, so if you don't get at least 1 heads, that means you must have gotten 0 heads. Because if you get at least 1 heads, well, if you get 1 head, then that's at least 1. If you get 2 heads, that's at least 1. If you get 3 heads, that's at least 1. If you get 4 heads, that's at least 1. And so the only way to not get, right, the only way for E to not occur, for you to not get at least 1 heads, is to get 0 heads. And so E prime is 0 heads. And if you flip 4 heads and don't get any, or if you flip 4 coins and don't get any heads, that's the same as getting 4 tails. And so we're going to compute what's the probability. So what's the probability of E prime? That's the probability of getting 4 tails. And all 4 tails, that means the probability of first coin tails and second coin tails and third coin tails and fourth coin tails. Well, these are all independent events because they're 4 different coins, so they're all independent. So we can use our extended product rule. We get P of first coin tails times P of second coin tails times P of third coin tails times P of fourth coin tails. Okay, and so all of these we're just asking what's the probability of getting coin or tails on a coin flip. These are all 1/2. 1/2 times 1/2 times 1/2 times 1/2. 4 times 4 products of 1/2, that's 1/2 to the 4th, that's 1/16. And so the probability of E, which is the probability of at least, I'll say, greater than or equal to 1 heads, that's equal to 1 minus the probability of E prime, which is 1 minus the probability of all tails, which is 1 minus 1/16. Well, 1 minus 1/16, 1 is equal to 16 over 16. So this is 16/16 minus 1/16. And so that's going to be 15/16. Okay, and so 15/16, that's pretty close to 1. And so that means you have 15 out of 16 times, you will get at least 1 heads. And I'm just going to leave it as a fraction. Let's do one more example. You draw 2 cards from a deck. And then the question is, what is the probability they are not the same value? Okay, and when I say the same value, I mean they're both 1s, they're not both 1s, they're not both 2s, they're not both 3s, etc. And I'll say draw 2 cards from a deck with replacement. So we are taking out a card, seeing what it is, putting it back, shuffling, and then taking another card. Okay, so our event E is different values. And so E prime, if they are not different values, they must have the same value. And so let's find the probability of E prime. So our sample space, this is just the number of ways to draw two cards with replacement. Well, the first card, we have 52 options. The second card, we also have 52 options because we're replacing it. And so 52 times 52 is 2,704. So size of S. Now let's find the size of E prime. How many ways can we pick two cards and have them have the same value? So what's the value? So task 1, choose a value for the first card. Task 2, choose a value for the second card. And these are independent. So when I choose a value for the first card, that's 13 ways. And they're equally likely, 13 equally likely ways. Choosing a value for the second card, well, if I've chosen one for the first card and I want them to, I'm looking for the size of E prime, how many ways can I have them be the same value? Then once I've chosen that first value, I only have one way to do it. And so the size of E prime is equal to 13 times 1, which equals 13. Okay. Oh, sorry, that's not true. My bad. I've chosen a value, right? I've chosen a value for my first card. There's 13 ways to do that. There are 13 values, and each of them are possible. Once I've picked that value, though, I put that card back. And if I want the same value, there's actually 4 ways. Because, for example, if I choose a 2, then after putting the card back, there are now 4 2s in the deck. I can choose any of those 4 2s, but I could choose the exact same one. I could choose, the same suit. It doesn't have to be the same suit. And so there's 4 ways to choose the same value, right? Because there's 4 of those values in the deck. And so the size of E prime is 13 times 4, which is 52. And so the probability of E prime is equal to 52 over 2,704, which is the same as 1 over 52. And that tells us, using our formula, P of E equals 1 minus 1 over 52, which is 52 over 52 minus 1 over 52. And that's 51 over 52, which, just for fun, I'll compute. That's approximately 98.1%. So you're very, very likely to choose 2 different cards. And again, this part might have been confusing, so let me just recap it one more time. There's 13 different values in the deck: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So you can pick, and they're each equally likely to be chosen. So there's 13 values. You can pick any of them. So there's 13 ways to choose that. Now, for your second card pick, again, you've replaced that card. You've taken it out, saw the value, you put it back and reshuffle. For your second pick, you need to make sure to get the same value, but it could be any suit. There's 4 suits. Each of them have that same have one of those values. And so whatever value you picked on your first pick, there's 4 of those in the deck. You can pick any of those 4 and it'll still be the same value. So there's 4 ways to pick the same value. So it's not just choose a value, it's choose the same value for the second card. And so there's 4 cards in the deck that have that same value. So there's 4 ways to choose it. Okay, so complementary probability is very helpful in certain cases where the complementary event is much easier to enumerate than the event you're actually looking for. Okay, that's going to be all for this video.